Okay, Trig 8.2, polar form of complex numbers. A rectangular form is that a plus bi form. And it's because when you plot a point, AB, then you create a rectangle. Of course, this is that vector also that you create. You create a lot of different things. Polar form is when you take an angle, say theta, and a distance r. So if you are given this distance r and this angle theta, you rotate that ray that's r units long that many degrees or radians, and you have found the point AB. So this a plus bi, which is the AB point on the plane, polar form is going to be in different units. It's r cosine theta plus I sine theta. That's polar form. R theta is the ordered pair for that. Sometimes some books use a semicolon to distinguish between rectangular coordinates and polar coordinates. Our book does not do that, but I think it's sort of a nice touch. Well, where did they get this r cosine plus I sine theta stuff anyway? Well, if you think about it and distribute that r, you get r cosine theta plus I r sine theta. Well, let's see here. What is x anyway? From this triangle, x and the y and the r, right? The cosine of theta is x over r. So x over r is the cosine, so what is x? R times cosine theta. That's this part right here. So it's just the a, or the x, changed into using r and cosine, and theta rather. Y over r is the sine of theta, but y then would be r sine theta, and this b becomes r sine theta, and you put the I first just because it looks nice. Now there's a shortcut for this. The reason we put the r outside is so that you can write this shortcut r cis, C-I-S, and this stands for cosine I sine, and then the angle is here. So you get the r and the theta and cis in between. That's the cosine I sine, and then theta. So this is the shorthand. Probably use that a lot because this is a really long thing to write. How do you find r? Well, r, of course, is the square root of a squared plus b squared, x squared plus y squared, whatever you want to call it. It's the same thing. What is theta? Well, we know the tangent of theta. If we use the a's and the b's, it's the b over a. If we use the y's and the x's, it's our familiar y over x. Now remember, this is where a or x is not equal to 0, because if it were equal to 0, we'd be on the y-axis and we could figure it out from there. So it's the same thing, only different. They're just using different words to talk about this. That's all there is really to section 8.2, and we need to just use this time to do a few problems. Page 370. Once you turn to 370, take a look at number 6. Number 6, we're supposed to, for each complex number shown, find its rectangular form, find its trigonometric or polar form. R is greater than 0, and theta is between 0 and 360. So they give us a picture. For number 6, it's -2, and I guess it's really not -2, it's negative square root of 3, which is close to a -2, and a -1. So it's, the point is right here. So this all the way around is the theta. So this is the point negative square root of 3, -1. Now that you know that, remember this is, I didn't mention, this is not really the xy plane anymore. This is called the Argonned Plane, named after a man named Argonned. He said, well, let's consider this the real number axis. That's the A's, all the A's are in that. And this, the imaginary axis, that's where all the B's are plotted. So this negative square root of 3, -1 is really the negative square root of 3 minus I, that minus 1I. So this whole thing becomes then that complex number, the Argonned plane. And we're supposed to do the rectangular form. Well, there's rectangular form right there. The polar form, we need to find out what theta is and what r is. Let me pull this out a little bit. If this is a negative square root of 3, or just square root of 3, and this is a -1, well, hold it. This is as easy as 1, 2, square root of 3. That means that across from the smallest side is a 30, from the medium side is the 60, and from the largest side, or you could use the Pythagorean theorem, whichever is best for you. So this is a 30-degree angle, this little angle here, which is the angle up here, and take that 180 degrees and add degrees, and add 30 degrees, and you get 210 degrees. So that's our theta. Now you could use the inverse tangent, but this was easier to look at and easier to figure out. What is our r? R is 2, theta is 210 degrees. So in polar form, this is rectangular. Polar form or trigonometric form, it's r, which is 2, cis, theta, which is 210 degrees. If you want the whole thing, it's 2, which is r, cosine 210 degrees, plus I sine 210 degrees. And now we've got this written a bunch of different ways. Boy, a lot of steps, more than 4. How about number 12? Number 12, graph each complex number. 2 minus 2i squared of 3. So A is equal to 2. And B is, they put that I in the middle there trying to fool you. It's a -2 square root of 3. So how do you graph that? In the Argonned or complex plane, the real axis, the imaginary axis, it's 2 on the real, and the square root of 3 is like 1.7 times 2. That's 14.323, right? 3.4, okay. So it's a negative, though, someplace down here. This is the 2, -2 square roots of 3 point. There's the vector. Does this make sense? Hopefully. After number 12, number 28.